Yeah. All right, let's do it. All right. Cool. Me. All right, clap your hands once if you can hear my voice. Yeah, we're all here. We're all awake. We're so tired, we're not even making noise to each other before we started. That's great. That's a great starting ground. Just so you know, I'm totally jazzed up. I've got enough energy for all of us, so hopefully I can get us to be some contagious. All right, so this is like an optional warm-up review for those of you who totally feel like they know what's going on and they don't want to review. There is a optional warm-up problem on Slack. For everybody else, welcome and join me in this review. So I'm kind of gonna play the room a bit and see like what we really need to do. So let's start off with like a little warm up to the review here. I want you to write a for loop that counts down from 10 to 0. Or actually, here, let me get more. I'm going to write it down here. Write a function that that takes a starting number and returns an array from that number down to 0. So it'd be something like this. If you count down, I'm going to say from 9, and I want the output to be like 9, 8, 7, 6, 4, 3, 2, 1. Okay, Alex? Yeah.
Is that an array you're giving us an example?
Yeah. So in the optional warm-up, you've got an array, and you're looking for the largest contiguous sum. Cool. Are we good with this, the people who are joining me in this review? And let me know when you got it. Oh, this coffee tastes terrible. Oh, maybe the milk's gone bad. Oh my God. Sorry. I won't have coffee now. I think there's no cream, so I put some fat-free milk in there, and I think maybe that milk's gone bad. I don't know. That was startling. I'll try it again in a minute. Just not used to it. Maybe it's not used to it. You think it's like coffee?
Yeah, just now.
Yeah, probably.
Oh, yes.
You have a couple things, but I'm
That's 6. 6.
It's not my right leg. You get my legs long. You're on the right track. 50 seconds. All right. Clap your hands if you can hear my voice. Clap your hands twice if you can hear my voice. All right, how'd this warm-up feel? Yay, yay, okay. Okay, yeah, so I was walking around a lot, and it looked like a lot of us were still struggling on this. This is something we've definitely got to be able to just bang out. This should be faster. If you're struggling with this, we've got to practice more on loops. So let's kind of go over this here. So we're making a function. First thing we're going to do is define a function here. So we're going to say function, count down. It's going to take in an argument, some sort of number. And now we know that we're going from a number to another, and we're going to be like repeating this action. So that should make us know we got to use a for loop, right? And we see the order. Now we could do a different order if we wanted to, and do unshift and push things in from the front and stuff like that. But I actually wanted everybody to just practice going in a loop in the opposite direction than what they're most comfortable with. So let's just start. We're going to need. And we know we're going to need an array to push everything into because we're going to be returning an array. So we need to make one. So I'm going to add an array here. Now I'm going to begin this for loop. I'm going to say, all right, for. And so now, what's the 3 things a for loop takes in? What's the 3 arguments? What's the first one? Winter? Starting point, great. Second thing? What kind of conditional? Okay. What's the exact kind of conditional? Ending conditional, right? So we're looking when this loop is going to end. We've got its starting point, and then this is when it's going to end. Third thing in the for loop is what? I'm hearing a lot of words incrementing. We're actually literally going down this time, right? So what are we really thinking? Christina?
How you move through how you're moving the stuff.
The step towards the ending condition, right? It doesn't matter if it's incrementing, decrementing, dividing, multiplying. Incrementing literally means moving one thing up by 1, right? So we're just taking a step towards the end condition. So for this problem, if I know I'm going to start at starting number, sounds pretty good. I'm going to do let I equal num. So now if somebody puts in a 9, I've got I is at a 9. My ending condition, I'm going to say while I is, I know I'm going down to, I guess I'm only going down to 1. I didn't do 0, so I'm just going to do while it's greater than 0. So while num is greater than 0. And what's a good step to move towards this ending condition? I minus minus, that sounds good. I'm going to change it up just so we can get used to seeing something slightly different. I minus equals 1. I minus minus also would work. Okay, so now we're inside. What do we need to do? Jonathan? Push what? Yeah, where are the numbers here? And what are those numbers called right now? We actually only have I available to us right now. That's a good, but he's right. We've got to push the numbers in. Where are the numbers? Well, the numbers are I. So we do output, dot push, I. I is going to start at 9. It's going to get pushed into our output array. I is going to decrement by 1 and become 8. It's going to check the condition. Is 8 greater than 0? Yeah, we're going to push it in. And then it's going to decrement to 7. And it's going to same, all the way up to I becomes 0. And it's going to say, hey, are you greater than 0? And it's going to say no. And it's going to go, all right, I'm not going to run that. So then we got to return something because it's a function. And so I saw a lot of people write their return statement inside of their for loop. Once you return from a function, it's game over. It's the same thing. It's like in life. As soon as you die, that's it. So you don't get to jump off a cliff and then go grab a gun, right? You get to do one or the other, or neither, right? But a function is the same way. The return is the end of that function. So if the function decides, that's it, I've had enough, I'm returning. It's gone out. The function's gone out. It's tried to make its fortune and fame. It didn't work out. It's returning home. It's done. It doesn't get to go out again. Okay? So that's what our return says. So if we put a return statement inside of our for loop, well, it better only hit that return statement if we're done with the function. So, but since for something like this, we want it to complete the entire for loop, we're not going to return until after. And we're going to say return output. And then that's it. I saw a lot of people think that this was somehow an array. I saw a lot of people go num at I. This was a common mistake that I saw. So that's pretty much the same thing as me saying the number 9 at some kind of number. And if you look at it like that, you go, no, that doesn't make any sense. Are we with me? Yeah, so that doesn't make sense. So neither will this one. Num is just a number. It's the data type of a number. Where's the array? We don't have an array. We don't need an array. Whenever we do array.length, that just converts it to a number. A for loop's whole thing is that it's going off of like a number. So we don't need an array. We don't need an array's length. We just need a number, a starting number, an ending number, something like that. Crispina.
Does the problem ask to include 0?
Down to 0. That's debatable. If you did it to 0, that's fine. That would just be the difference of equal to or not equal to. What else did I see a lot of people do? Yeah, it was mostly that. A lot of people automatically incremented I plus plus. We're decrementing, right? It's not. It doesn't have to be plus plus. It's the step towards, and we should make sure this runs. Ooh, like a type. Countdown at 9. Oh, it doesn't work. Let's see why. Well, that's an interesting error.
Yeah, I got that.
Because it says no, it's greater than 0 should be I.
Ah, good catch. Right. So Diana says, well, num is greater than 0. Num's always greater than 0. We're not changing num. We want to do while I is greater than 0. That's a good catch. Well, this is very important. Like these little loops are tricky, right? But just have to reevaluate exactly what's going on. All right. Are we ready for another? Yeah, Leo?
How about the for loop solution? For loop solution.
We wouldn't, for each is an array method. This is just based off of numbers. So there wouldn't be a for each solution. You can only call for each on an array. And since we never started with an array, we just started with a number, we don't want to use for each. Good question. All right, let's try, are we ready to try another one? All right, let me think. All right, so let's write a function that prints, no, that takes in a starting number and ending number and returns an array of all numbers in between, including the start and ending number. Questions? Oh, okay, I'll make an example because I'm seeing some funny faces. Range, this would take in like, I'd say 4 and 90. And, I'm not do 90 because I'm gonna type it out. And then it would give back an array of 4, 5, 6, 7, 8, 9. Becky.
You want your array to fall to the one input? That's the revolving 0.
No, that's a good question. You can if you want. That's bonus, but I don't. Just want to. I'm only worried about like the loops at the moment.
So the start will always be right? Yeah, so it's out there where I'm going to start, right? Oh, you're saying I'm sorry, as long as it's hard, it's less than N. So I get to start.
By weeks and a half, yeah.
So as after we've gone through the root course, what kind of other variables? So go from -2, we have -2. There's some rules in there, but that's not a bad way to approach it. So for the wild, you have to instead of what call it as one data. So unless you're like adding up two numbers, the white dot script interprets the addition sign and it's going to stress forces. I mean, in a string, it just makes strings to try to make it work. Otherwise, it's so you can't add it, okay? Yeah. Yeah. So how else do you choose that number? That's right.
Are you in your phone?
All right, clap your hands if you can hear my voice. Clap your hands 2 times if you can hear my voice. All right, how'd this one go? Better. I'm still seeing a lot of tricky things out there. So let's go over it. Let's break it down. All right, so we've got a function called range. So we'll start, well, let's do ES6 this time. We'll start with range. And this takes in a start and an end. Ooh, a new version. All right. Gets rid of that. Okay, so what do we got to do here? What are we thinking? Nikki? Yeah, so we know we're outputting an array, so we've got to, and we have, if we remember, we still have no arrays available to us. So let's create one. Let's say let output. Make it an empty. I got it. Make it an empty array. All right, something like that, whatever. And now what are we gonna do? Let's see, next. Yeah, some kind of for loop, right? And so what's a for loop? How's it start? What's a for loop? What's the first thing? What's the argument? The first argument in a for loop. Someone who has it. Kelly. The starting point. Yeah, good. So for this starting point, yeah, let's say let I equal start. All right, what's the next argument in a for loop? Jonathan? The ending condition. All right, so when's a good point for this to end? When it's equal to the end? So yeah, we might want to say like kind of like in our heads, while, right? So we say I is less than or equal to end. Okay, and then what's the last argument in a for loop? What is it? Step? Yeah, step towards the ending condition, right? So which way should we be going here? I plus plus or I plus equals 1, right? Same thing. Okay. So what's next? Trey.
We push I to the
That sounds good. So he says, let's push I into output. I is going to represent every single number, and we're going to stick each one of those numbers in our output. Sounds all right. Are we done, or do we have to do anything else? We have to return out of the function. Why?
because every function, or to get an output of the outcome.
Okay, right. To get an output, I have to put a return. If I didn't put return, what would this function return? Undefined, exactly. So I'm going to return output. Let's test it. We'll try 4 and 9. Looks good. So someone said to me, well, hey, this works, but it only works for if the starting condition is less than the ending condition. Oh, that's true, but let's say, what if we didn't want that? What could we do? So what if we didn't care if the start was smaller than the end? What about if instead of that, so there's 2 possible ways, right? Let's say we either say, all right, the ending is smaller, so just return an empty array, or we say, all right, we're going to give you an array from the smallest number to the biggest number of the two you gave me. How would we do that? Crispina?
I heard you say if a lot, so I'd probably do if statements for both if else statements.
If else statements? Where?
If above the for loop.
Above the for loop. Yeah, so we could do some kind of if statement there. What else? What's another option? Neeleen?
Starts and end, like feel that's also a tendency. If starts is less than and that starts equals starts, and if starts is more than end, that's end equals start. That would be fine.
Yeah, I think so. So what Neeleen's saying is we could redefine which one here. So maybe instead of start and end, I think of biggest and smallest. And so I would just say like let smallest equal, and then I could say start less than end. Do start, otherwise end. This is a way to get the smallest. If I wanted the largest, I could go let largest equal start less than end. I'm going to say and start. Is this confusing to everyone else? Anyone else? JR?
So what exactly is that?
Sorry?
What exactly is it?
So this is a ternary. Remember these? All right, we'll talk about them. Let me just correct a couple things here. This is going to become smallest because this is our start, and this is going to become largest. So now when we put in 4, 9, it works, and it should work if we put in 9, 4. Yep. So now it doesn't matter. So what's going on here? Let's talk about the ternary. A ternary is a fancy if-else statement. Literally. So if I wanted to say if start is less than end, I would say something like smallest is start, else largest, or sorry, smallest is end. Do we understand this if statement? Yeah? Janelle, is that a question?
No.
Oh, okay. So I'm super eager for questions. If you have questions, please just even go like that. I will call you. Okay, so this is our basic if else statement. We say if, we put in parentheses some kind of condition, and then we say what we want to happen if that condition ends up being truthy, right? And then we say else. So if we didn't hit that first one, else, we're just going to do this. And so for this one specifically, I'm checking if start is less than end. And if it is less than end, our smallest is going to be reassigned the value of start. Else, our smallest is going to be assigned the value of end. So when we go up over here, we can look at this as two separate things. This is my variable declaration and assignment. I'm saying let smallest be, right? And then this end is my if-else statement. Oops, I'm saying if start is less than end, that's the conditional, and then I'm throwing in a question mark so you know to read it with an emphasis going up. So, start less than end. Then, if that's true, we're going to do our first thing after that question mark, which is start. So that would mean let smallest assign the value of start. Else, after the colon, we have end. Questions on that? Okay, so let's prove to me that we don't have questions on that. I want you to write in a function that takes in, or I'll write the direction. Write a function that takes in two numbers and returns the larger number. Should be a one-line function using ternary. Okay. So, I mean, you can use like the function definition and then the one line. That's fine. You don't have to use ES6. Bonus points if you do.
It assumes that one is definitely an argument.
Well, if it does, if they're the same, you would just return one of them. That makes sense.
Sorry. Yeah, that's right.
So it's all about how you set up yourself. All right, clap your hands if you can hear my voice. Clap your hands if you can hear my voice. Excellent, great job. Amazing that you could understand that. I think a lot of you just figured that you knew what I was saying. Okay. How did we do on our turn here? Everyone nailed it. Okay. What? Oh, okay. Okay, so let's solve it together. First thing we needed was a function. Beautiful. Def, oh, that's Ruby. Const larger. This takes in a number 1 and a number 2, right? I'll do it on 2 lines for now. So then, our goal is to make this in 1 line, right? So we have to use that ternary to figure out which one's larger, and then whatever the result of that is what we want to return. So I saw some people writing multiple returns or doing multiple assignments, and we don't need to do any of that. We just can have that ternary, and then whatever shall be, and then we can just return that. So it should have looked something like return. And now we put our ternary. So we can say num1 greater than num2. So if num1 is greater than num2, what do we want to return? Num1 else. I'm going to just guess what we think num2. Questions on that? I know ternaries are a little bit tricky, but they're definitely something you should know. And they can clean up your code substantially. All right, let's do another problem. Okay, I gotta think of something quick. Okay, so I want you to write a function that takes in a high number and a divisor. Okay, and I want return all numbers from 0 to divisor 0, to high number that are divisible by divisor. So what's that look like? That's going to be called, well, I don't know what we can call it. What's a good name? Want to have a name? Sure, I like that. Thank you, guys. I like 2 people had the same name I did. That makes me feel really bad for not having thought of a name. And we'll say let's say we do 20, and I put in 6. We should get something that looks like 6, 12, 18. Okay? And you're off.
What do you use?
It was good. It was good.
Returning is almost as if you're killing. So you don't get to do it again. So you want to return only at the end.
Without this, I would take it seriously. If you this. That's the website you want us to send. I just took it from
That's such a silly thought. Not me. Related to love. Oh, those little, all the little puns, right? Sorry for man for so long.
Oh, yeah, it's gonna be this.
We're getting out of here. Just remember, as soon as we hit return, that's it.
Oh, you said no? Your time is way longer.
Yeah. That's gonna throw in there. So we want to collect all these so we'll do our first couple problems today. We were keeping an output, right? Return all numbers from 0, but we see an example problem as well. So if we can keep track of those numbers somehow, then we can return them all. Okay, no problem. All right. Clap once if you can hear my voice. Clap once if you can hear my voice. All right, cool. Everybody listened. That's pretty impressive. Okay, how'd we do on this one? It's a little bit harder. Yeah, no, okay. Mediums. Okay, so let's talk about it. So this is a fun problem because there are a bunch of ways to solve it. And we get to only choose one. So sometimes if you start solving a problem with multiple ways in your head, even if you might not realize there are multiple ways, I worked with some people on this problem and they were like, well, I'd ask them how they would do it and they would say, well, I would take the number and then I would add it to itself right? 'Cause 6 plus 6 is 12, and then I add it to myself, and it'll be 18. And it's like, okay, yeah, that's great. And then when they start to write it, they do like they increment I by 1. And it's kind of like, well, that's another way to solve it, but we got to choose one way. So we can do all the ways, or a bunch of the ways, but to start, we got to do one way at a time, right? So we got to first write function. We'll call it divisible by popular demand, and we'll say I num and divisor, right? And I know we probably already know this, but remember, we put these like words in because we don't know what will be passed in. We cannot use concrete real numbers. It defeats the point. We want to be able to make it so our function can take other inputs. So by doing this, we're just like saying this is what we're going to be calling an input that will someday be passed into the function. So we know we're returning what kind of data structure? An array. And do we have an array available to us right now? So what do we need to do? Let's make an array. All right, so we go let output. Chris, can you close the door so I'm not shouting out into the abyss? I only want to shout at you guys. All right, so let's get going. So we got our output. So, okay, so what do we need to do? What's next? Janelle? For loop? Sounds good. What's the first thing that goes in the for loop? A starting condition? Or a starting point? Janelle, what should we use? Let I equal to divisor. That sounds good. So if we wanted to do 0, that'd be okay, depending on how we do our logic. But since we know that it's always going to be starting, you know, if we want 6 to 20 and we go up to 18 or whatever, we keep starting at 6. We might as well not do those first 6. So that's fine. What's the next argument in the for loop? All together. 1, 2, 3. Ending condition. Excellent. Some people were like a little slower waiting, I think. And that's okay, but we will do it again and again. So our ending condition, when makes sense for us to stop for this? At the high number? Sure. So while I is less than or equal to, we think? Or equal to high num. Sorry? Yes, if we want to include the high number, we would put or equal to. And I want to include the high number. Winter. Yeah, but if we look at our we could put I as 0, but we don't have to. If we look at our output array, it doesn't include 0. What?
No, Karina was like, see, and I was just saying that's what the question is. So, okay.
So it's very important to like keep track of the input versus the output. So if we can see the output, it gives us kind of like a goal to move towards. That's like always something to look at and think about. How do we move towards this goal? Okay, and then the third thing in a for loop is what? 1, 2, 3.
Stop.
Thank you. Whoa, fast. I like it. Step. Let's all be that fast. Step towards the end condition. All right, let's all just say it. Ready? 1, 2, 3. Step towards the end condition. All right, I hear every day increment. No, it's the step towards the end condition. Always and forever. Napoleon Dynamite reference after credits. No one. Okay. So we go, what's a good step for us to take? Janelle? I plus equal to 5. Yeah, that's a really efficient one. I like that. So she says we can do plus equal divisor. So I know a lot of us did it a different way, and we can talk about that and show that after this. This is a better way. Why is it a better way? Because a lot of us decided we just want to increment I by 1, and we threw an if statement in there, and we checked if that I was divisible by divisor, right? Is that fair to say a lot of us did that? Everyone's like, I only looked at mine, but yeah. So that's fine, but it's also pretty unnecessary, right? So like if I was looping up to 1,000,000 and I wanted to go up, my divisor was 250,000, and we were going up by 1, if I start there, I end up doing about, 1,000,000 operations. But if I add it up by 250,000 each time, I only end up doing about 4. So that's significantly faster as the numbers grow. Does that make sense, Sarah? All right, so with this one, what's left? What do we have to do now? Someone else, other than Janelle. Mona? Okay, so we could check if I is divisible by the divisor. So that comes more important if we were to be incrementing I by 1 each time, because we wouldn't know if it was divisible by the divisor. But since we're adding the divisor to itself over and over again, it's safe to know for sure our I already is divisible by the divisor. Perfect. So Mona says we can push it into the output. We can go output.push I, right? And then what do we need to do? That's right. I like that. Aaron said it. Return outside of the for loop, right? Because we want the whole for loop to run, and we'll return our output. Let's try it. Visible, and we'll say 6, 20. Thank you. So that could be something to fix later on, right? Same issue, apparently. Okay. What is the error? Start is not defined. I'm not using start. Maybe it's just. There we go. Good. Our code's all right. That was something from some random thing higher up. Okay, so this is one answer. This is a great answer. This is a great answer because we bypass a lot of steps, right? We get rid of the having to do if statements. So that makes our code a little bit easier to like follow in a sense. And we don't have to check every single number, which makes our code significantly faster. So this is pretty great. You do have to have the math foundation of idea of like, hey, like if it's a multiple of that number, then it's also divisible by that number, right? Because 7 times 1 is 7. 7 divided by 7 is 1. 7 times 2 is 14. 14 divided by 7 is 2. Does that make sense? I can write it down if we're confused on the math. Okay, so let's do the other route as well. So we're gonna go function divisible. Let's say high num and divisor. Right, and now we get to go. All right, let's get our output. Same thing that we've done. And then we did this for loop. And a lot of us did I is equal to 0. And that's okay, right? And we go I is less than, although, yeah, well, whatever, we'll get to it. High num, we got to as well. And then we did I plus plus. A lot of us did that. And that's all right. So if we wanted to go from here, we would do what Mona was talking about. which is we got to throw in a conditional statement. So she said, like, if I modulo divisor equal to 0, meaning it's divisible by it, we would push it in. And we got to make sure that we get all the way out of our for loop before we return our output. Still works, but now we have a 0 in there. So we go, oh, don't really want that 0. I'll just start a division. Questions on that way of solving it? Crispina?
Would the time complexity like graph really change that much? It just has like one for loop.
Oh, let's see. I'm trying to think of how I would actually like say what the time complexity is, because the time complexity is super dependent on the divisor. I guess I would say that the time complexity is the divisor. Well, yeah, that's what I'll say. So I'll say kind of like the time complexity. If we do it this way, our time complexity is solely based off of the high number, right? Because for every number up to the high number, we're touching. While the other one, the time complexity is really high number divided by divisor.
Can I ask you to give an actual element, like what it actually is? Like if it's low and if it's really, really high?
So not really like they wouldn't ask you to like say in n terms so much. They would say like they would have you just kind of talk about it, and you say, well, if I were to solve it in this way, where I increment I by 1 every single time, my time complexity would be high number. So that if this is n and this is m, this would be n. So as this would stand, you could say O of high number, or right, O of n, but it's dependent on high number. On this one, where we're incrementing by the divisor each time, I would say that the time complexity is O of high num divided by divisor, or like O of n divided by m. Does that make sense? Does anybody have any questions on how I'm coming up with that? Ever not?
More like I don't know
Sure.
why is it high number?
That's a great question. Okay, so let's first make sure we understand the slower case here. So in the slower case, we've taken in a high number and we've taken in this divisor, and we want every element that's divisible by that divisor, right? But in our for loop, we're incrementing I by 1 every single time, and we're checking every single number. So we're going all the way up. We can kind of disregard divisor. But we're going all the way up from divisor, or kind of like 0, all the way up to that high number. So if the number is 100, I have to go all the way up to 100, every single number. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If it's a million, it's all the way up to a million. 1, 2, 3, 4, 5, 6, yada, 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 a million. And so we go, our time complexity is O of our high number, or O of n. It's
And is the actions?
yeah. So n changes with our input size. It's how, so if it's a linear change, so for every one number bigger of n, I have to do one more operation. That's considered a linear operation. So that's how we're getting this O of high num, or O of n here. You want to just call it n. Here, where we're incrementing instead of by 1, but actually incrementing by the divisor, we only have to do as many operations as our high number divided by the divisor. So if our high number is 49 and our divisor is 7, we only have to do 7 operations because it's 49 divided by 7. And so that's why here we have O of high number over divisor, or O of n divided by m. Leo,
How about the
sorry?
divisor?
Divisor,
Negative.
if a divisor was a negative number, I mean, our problem might be set up a bit differently, because because we've been operating under the assumption that we're only using positive numbers. So if it was negative, we'd have to we'd have to rewrite the function and then decide. So questions on that? Okay, so the next challenge of the morning is to write this function again. Let's write it in this style, but this time use a while loop. All right? We'll come back in 10 minutes.
Yes. Yes. Barcode?
Yeah. All right. Clap your hands once if you can hear my voice. Clap your hands 2 times if you can hear my voice. Awesome. All right. So how do the while loops go? Yes? Oh, good job. Okay. Yeah, so pretty good. I know a lot of us have not been using while loops that much. Very cool. I love steps. Okay, so let's write this one out together. Let me comment out our pass. Okay, so first thing we do when we're writing a function, what do we need to do? What? Yeah, declare a function, right. Come on, these are answers we all can answer. Visible. This takes in a high num and a divisor. Okay, so what's the first thing we want to do? Someone can throw up their hand. It's all right, Nikki. We need to create an empty array, right? Because we're going to be, our output we want to be is an array, and we don't currently have an array, so we must have to make one at some point, right? All right, cool. So we've got our empty array. What's next? Why don't we, Winter? Yeah, exactly. So Winter says, we're going to be doing this loop, and we still are going to need this I, because we want to check I. So let's define I so we have it. That sounds great. What should we define it to, Winter? Divisor? That sounds great. Great. So now we've got this I set to our divisor, which looks a lot like our inside of our for loop here, right? We've got, so far it's pretty similar. We've got this divisible high number divisor. We've created this output array, and then inside of our for loop, we've got this let I equal to divisor. Oops. And so what do we think our next line is inside of our, this one? Michelle? The while loop, right. So while, and what's a good condition? Yeah. Right, so while I is less than or equal to I num. And if we look, this should also look pretty familiar to our second argument and our for loop. Right? It's actually identical. Do we see that? Okay. So then we can open up our curly braces. Now there's something I usually do when I write my while loop to make sure I don't forget, because I don't want to get caught into this infinite loop, which will inevitably happen if I start writing code. And so if you were me, what would you do next? Thank you, Winter. The step towards the end condition, which for this situation is what? Morteza? I plus equals divisor, right? And this should look pretty familiar to this one, right? We've done all of these things. We know we must be in a loop. We're just calling it slightly differently. So now we got to come up with the logic. And if we remember from our logic before inside of our for loop, we did this on line 46. We did output.push I. Well, let's do it again. Output.push I. What else? Am I missing anything else? Yeah, I'm missing the return, right. Where should it go? Why? Excellent. So Winter says we got to put our return outside of the while loop. Otherwise, we'll just return from our first push. So let's try it. We go return output. And let's try it. Let's call divisible. Taking 20 and 6. All right, it works. Great. Questions on how that's working? Eric.
When it comes to the output, the precision would be like, does it have to be in a specific order, or does it have to be?
Great question. So Eric's asking about line 69, line 70 and 71, and he's asking about the order of how things are going to run. And he wants to know if we can put line 71 first. Well, let's try it and just see what happens, and then see if we can explain the behavior. So if I put that line in there first, I get 12, 18, 24. Why? Someone who hasn't spoken for a while. Kenya.
Before you push the divisor into the array, over the increment by divisor.
Totally. So Jania says, if we do it like this, we're incrementing I by the divisor, and then we're pushing. So we're starting one behind each time. Totally. Perfectly correct. So I'm going to go back. All right. We ready for one more? All right. So I want you to, let's see, to write a function that takes in a number and returns an array of all numbers from that number down to 0, dividing by 2. Write a while loop and for loop version. Okay, so what's that going to look like if I put in a divider? I put in 50. I want this to say, that should be 50. Start at 50. 50, 25, 12, 6, 3, 1, 0. Questions? All right, go for it. This was the output that I ran after changing it. Your output's correct. This was when we switched 70 and 71. We implemented the visor. Yeah, good job. And if you get an answer without the 0 at the end, that's fine. I don't. That's okay too. You can also have an answer that looks like that. That's a little less complicated. That's still a thing.
You're starting at what number? Like, where is this divisor? 0.
Clap your hands if you can hear my voice. All right, so I'm going to give you guys a little bit more time on this one, but I'm going to give you guys a little bit of a hint as well, which is that like inside of a for loop and stuff, right? This step, where's my? I got to find my mouse. Here we go. This step here inside of our for loops, this I++ or I plus equals divisor. I mean, this looks a lot like math to me. So maybe we can do other mathematical operations in our own for loops. That's your hint. You might be able to do math inside of that third argument.
Zeno's paradox, bro. Yeah, just do integers. Or math, or maybe math might be better because maybe you don't get responses and then if you don't find what you want to do, then math is something else. So you just so use math. One hour is so real. Well, that. How would you do it? Oh, man. It'll still work.
And I said, yeah, exactly.
All right, clap your hands if you can hear my voice. Clap your hands twice if you can hear my voice. All right, so let's go through this. How did we do on this success rate? How did we feel? Yay, nay, okay. Okay, some yays, some nays, some okays. Pretty spread out. So let's go over it. I'm gonna start out by commenting on our previous garbage. Excellent. All right. So we decided we were going to write a function. What's the first thing we should do? All right, there we go. Now we're live. Here we go. Function. Maybe divider is not the greatest word. Maybe we should call it haver or something. Heifer. Heifer. I like that. Just took in a number. All right. We want to do for loop or while loop first? All right, we got a nice big unanimous for loop there. So what should our first step be here? Somebody throw up their hand. Crispina?
Make it empty array.
Yeah, so let's make an empty array. We're trying to return an array. We don't have an array. Let's make one. So we say let output empty array. Perfect. Next thing we're thinking about doing? Thomas? For loop. I like that. So what's the first thing you think we should have? Yeah, so this is the starting point, and he says a good starting point would be for I to equal the number. Yeah, okay, let's try that. Next, I greater than or equal to 1, okay, or this greater than 0, right? And that's the, what kind of condition? The ending condition. Oh, good catch, Renat. Here we go. Let's all be awake here. Nice, thank you, Renat. And so he says, so while I is greater than 0, we want to keep running. And then the next thing we're doing is what? What kind of thing? The step. So what's a good step? Yeah, so that's not bad. So Nikki says we could do I divide equal by 2. That's good, right? That could work. So what if I put in the number 25, though, and we know that I starts at 25, and we don't want it to be 12.5. What can we use? Yeah, okay, I'm hearing some people say math.floor. Okay, so we can use math.floor. We might as well use it here. So if we've noticed all of our steps here in some way, we're really doing we're doing variable reassignment, right? Even though usually when we see it, it's just like sexy plus plus or something, right? Or minus minus. But really what that is, and sometimes we do this other like syntactic sugar, if like plus equals 1. But let's not forget, this is really just I equals I plus 1, right? This is like what it is. Does that make sense? So if we do I divide equals 2, which is very nice syntactic sugar, it looks beautiful, but we got to use math.floor somehow. Well, what if we broke it up to do I divided by 2? Now it seems like we might have a good spot to add math.floor. Where can we add it?
After the equal sign.
Yeah, Crispina says we can add it after the equal sign, because this is where we're doing our division. This is what we're going to want to be flooring. So we can do floor. Great, and that should take care of that. So we're going to start off with 50. I is going to be divided by 2. This is going to be 25. This is going to be divided by 2. This would be 12.5, but then it's going to be floored to 12. So that's kind of looking a lot like the output array that we're looking for. So what do we need to do? Is somebody who hasn't spoken, maybe? Leo. I don't put that push? Okay. What do we want to push? Yeah, we want to push I. Sounds good. What are we missing? That's right, we're missing our return, right? We've wanted to do our full loop, so we're returning outside of the for loop, and we're going to return output. So let's give it a shot. Let's say halfer, 50. Oh, looks pretty good. Morteza. Yeah, we could do math.floor inside the push. I think. Let's try it. We might have to change some other logic though. And it will be a little less pretty. What, it's a greater than 1. So we'd have to do a couple changes there. But the other way is a bit more intuitive. I really want to emphasize this idea that these statements inside of our for loop, oh man, this is just code. This is just math. So we can declare variables in here. Our conditionals can even be a lot longer than just like I greater than or I equal to. It would be I greater than and this, or I is less than that, or this variable is false. Like, we can do a lot more than just greater than or equal to. Same with our steps. We can do all kinds of math operations. We're not?
I have a question regarding like the use of I as a variable because like so far I've been using for loops using the I as an index, and we're using here I as like a number that we're doing operations on, and like what is confusing me for that. So like I solely as an index, then I was like I don't know where to like it is as an index, but here we're using it as a number, and it's like a matter of like declaring the I. Maybe we can call it like the number, like that's the current thing, and then
Yeah.
divided. I don't know.
So that's a great point. So we're not saying, we use I all the time, and she always, associates I with being an index, which makes a lot of sense. And so she's saying that because of that, she tries to figure out like where this array is and how to use an array. And she's totally right. If you want, you could change the variable I. You could call it anything you want, but I'm going to stick with I because I is standard. And that's kind of been like one of the reoccurring ideas of today's morning review, which is that I is not an array or has nothing to do with an array. I is just a number that we're looping through. Sometimes we use that number to index into an array. Sometimes we don't. So Takia asks, how come when we put the math.floor in the inside of our output, we had to change our condition to 1? That's because as you keep dividing a number in half, we'll never get to 0. But we will get to 1. Good question. All right, do we feel okay on this? Yeah, Crispina.
I think my question might be the same as hers, but I don't really understand her question. My question is at the stat part.
This?
So you said yes. You said that the I plus plus is the same as I is equal to I plus 1.
Yes.
Well, how is that working in terms of like where doing I is equal to? Because I already see like let I equals to none. Like it doesn't have nothing to do with each other. Like on the other side.
Okay, so I think I get your question. Crispina's kind of asking about like how this I relates to this I, sort of, right?
So we're on the other side of the for loop. We're already saying like we're defining I there, and then like I kind of see like I equals math.floor. Like I'm like, wait, we already did that. So
Yeah. So this is okay. Great. So this, yeah. So this goes back to like what is inside of the for loop. First argument is where we want to start. So we are creating this new variable. We're declaring this variable I, and we're assigning it a value that we desire. The middle one is that ending condition. So whenever our I meets that ending condition, we know to stop running our for loop. And this third thing is the step. And so the step, as we usually see it, is written as plus plus. Is how we've seen it a lot. But this is this. I equals I plus 1. It's just a, oops, this should be I. It's just a syntactic sugar. It's just makes it more attractive, prettier, quicker to write. So the whole time we've been using for loops is on this step, we've always been doing variable reassignment. So just instead of writing I plus plus, we could write that. And so in our example, we're just writing that. So we're just reassigning the value of I with each iteration.
So you're telling me that the structure of the for loop is saying that that has nothing to do with each other. Because the thing that I'm like, my brain isn't letting it happen is reassigning it over here and then reassigning I over here.
So
like, that's okay. That has nothing to do with.
Well, it does. This is the first time we're assigning it. This is reassignment because it's already been assigned. That's why we don't have. Oh gosh, why does that always happen? That's why we don't have a declaration like let a const in front of our I over here, is because we already have the I. So the first way that this runs, let's say with 50, we go I is equal to 50. So if I were to keep track here, I have an I, and it's equal to 50. When we check, is I less than, is I still greater than 0? And we say, yep. And we go, all right, now you run the code. We don't actually get to this step until the end of the block. So we run the code and we push in to our output 50. So I'll keep track of an output here. So now we got a 50 in our output. Now we do our third step of the for loop. And we say, all right, I is now going to be the value of math.floor I divided by 2. So 50 divided by 2 is 25. Math.floor of 25 is 25. And so now that's the value of I. So this gets changed to 25.
Thank you so much for that.
You're welcome. I'm going to keep going. Anyone else? So now we check this condition again. So we say, is I greater than 0?
Yeah.
Yes, right. Okay, we still know that. Great. So now we push our I into output. So we go over here and we get 25. Now we hit this. So we go 25 divided by 2 is 12.5, right? Math.floor 12.5 is, so that's now the value of I. So I gets changed 12. Is I greater than 0? Right. So we're going to run it again, and we get pushed in. So now we get our 12 in here. And then after we've gone through our block of code, we have to do our step. So we go 12 divided by 2 is 6. Math.floor of 6 is 6. And so now I is 6. And we go back up. And we say, is 6 greater than 0? Yep, 6 is greater than 0. So we're going to run our block of code. Output that push of 6. So now 6 is going to get added to our output. And we're done with the block, so we go back up and we do our step. So 6 divided by 2 is 3. Math.floor of 3 is 3. I becomes 3. I greater than 0. Bada bing. We run our code, and now we got we're going to push it in. Bada boom. We get through the block of code, and we go, all right, 3 divided by 2 is 1.5. Math.floor 1.5. Just 1. So now I gets changed to 1. And we go, all right, let's run this code. If 1 is greater than 0, oh, it is. Let's run it. Let's push it in. So we pop in the push in the 1. And we finish the code. And now we go 1 divided by 2 is 0.5. Math.floor 0.5 is 0. I becomes 0. Is 0 greater than 0? Unfortunately. It's not. And so we leave our for loop and we return our output. Questions on how that's working? All right, so let's write our while loop version. So we can comment this beauty out. And let's do it. So we'll do a constant of heifer. Takes in what? Takes in a number. And so this is going to be pretty similar, right? So what's the first thing we want to do? Janelle. Let output equal empty array. Is that what you said? Awesome. Thank you, Janelle. What's next? Yeah, a little bit louder now. That's what I'm talking about. He says, let's define I. Sounds great. Let I equal none. This kind of looks pretty familiar to our for loop. So now what do we need? Some kind of while loop, right? So we go while condition. Give you a hint. It's the same condition we use for the for loop. I is greater than 0. Awesome. So let's just keep going because we want to make sure we don't forget. Let's do our step. What's our step here? I equals, Eric, a little
I equals math.floor.
Math.floor. I divided by 2. Sounds good. We're going to do that at the end of the while loop. I always write it first so I don't forget. I hate infinite loops. They freak me out. So I do it like this. So now what should we do with each iteration here? Someone else. I know you're on it. Trey, what can we do in the code block here? Yeah, output dot push of I. And when do we want to return? Outside? Sounds good. I love going outside. Let's do return, and we'll do output. And let's try it. Well, looks the same. Any questions on the while loop? It's really good to know how to write both. There will be times when you will want to write while loops. We haven't had to do them as much, partly because of the type of algorithms we've been writing. But as we get into some more complicated ones, sometimes the while loop makes it a little easier. Good? All right, so from here until lunch, if you need more review, keep reviewing all this stuff. Otherwise, Reed has posted a practice exam for the Unit 2. Right? Do you have anything to add?
We don't get questions.
Yeah. All right. Have fun. Oh, yeah, okay. It's a standing ovation. Yeah, those of you online.